Hello friends, welcome to FreeCAD tutorial, and in this tutorial we will model gear pump body. As I have already did it, as you can see that with the help of this 2D drawings, and I will show you from the scratch how you can do the same in FreeCAD. So let's start. So I will close this file and I will create a new file, and I will create a new body, and I will press the space bar and on my origin planes. So before starting we will select our base plane from where we draw our first sketch. So we will select this XY plane and I will say sketch, and now we will draw as it is. So simply I will select rectangle and draw a rectangle here, and I will hide my origin plane. Now I will make my rectangle symmetric, so I will select these 2 points and center point, and I will give dimension 15, which is here, and overall is 25. So I will select this and I will give 25. Now I will move my dimension. Now I will go to the task and close, and we can see here the total thickness is 6 mm, or we can say height. So I will click on pad and I will provide the 6 mm. So we draw this dimension, and this one, and next one we will make this cut. So I will select this face and I will say sketch, and here I will draw a rectangle here, and I will delete these 2 lines, and I will go for 3-point arc, and I will draw a arc here, and then I will make constraint tangent. Select this and this, make tangent. Same with this and this, tangent, this and this, tangent. Now we can see here the total length of the slot is 16, and here is a radius 4. So 4 plus 4 is 8 minus 16. So center to center distance will be the 8 mm. So I will select this point and this point, and I will provide the dimension 8 mm, but this should be in line with our origin point. So I will select these 2 points and I will say vertical, and as you can see that our slot is not symmetric, so we will make it symmetric. So here is a conflict, so we will resolve that. I will delete this. Now radius is here, we can see R4, so I will give here radius 4. Now our sketch is fully constrained. I will switch to the isometric, and now we will read this cut dimension, this slot cut. So we can see that in a side view it is a 3 mm here. So I will come out of the sketch and I will go for the cut, and I will give depth 3 mm, and I will say OK. Now the next feature, we will draw this hole of 6, which we are seeing here in the hidden, which will be at the bottom face here. So I will select this face and I will say sketch, and you can see here this hole is on the edge of our slot here. So we will switch to the isometric and we will project this edge. So you can see that once I selected this external geometry and selected this edge, this is got projected on this face. Now we will draw a circle and make it constrained with this projected line. Now our this whole diameter is 6 here, which we can see here. So I will give it diameter 6. Sorry, this is 5. This is 5. And now we will see its depth is 3 mm. So I will close it and provide the depth of 3 mm and I will say OK. Now I will switch to the isometry. Now we will make this half circle R1.5 on this face. So I will select this face and say sketch, and we will project the same edge here. Now we draw a circle here and make it constrained with this line, and it is R1.5, so I will select radius and give R1.5 and I will close it, and we can see that it is a through wall. If you see its projection here, so we can say that this is that R1.5, it is through wall. So we will remove the material through. I will say cut and I will say through all and I will say OK. Now we can see here a hole of diameter 4 on the surface of our slot cut. So I will select the surface and I will say sketch and I will draw a circle here, and its diameter is 4, so I will select this one and I will go for diameter constraint and I will give 4 mm. You can see here this whole position is not defined here, but this slot has been defined, means this slot center and this whole center is the same. To find the dimension, we will project this edge of our slot. So you can see that we have got the center point here. Now I will select these 2 points and I will say merge. So here is a conflict of dimensions, so we will see. So I will delete it. I will delete it and I will make again here circle, or better I will draw on this point. Now I will give it diameter of 4. So you can see that it is constrained. Now I will close it. So this depth is from the face, it is 4.5, and we have already made the 3 mm slot cut here. So 4.5 minus 3 is 1.5, so this depth is 1.5 from here to here. So I will go for cut I will go for cut and provide the depth 1.5. I will say OK. Now I will switch to the isometric view. Now we will adapt these 4 holes here, here, here and here. So I will select this face and I will say sketch. Now I will draw a circle here and its position is 3 mm horizontal and 3 mm vertical, and hole diameter is also 3. So I will select my circle. First I will provide the diameter constraint of diameter 3, and then I project these two edges here, and then I will provide vertical and horizontal dimensions 3. So you can see that hole has been fully constrained. Now I will close it and I will go for cut and I will say it through all. Now here we will pattern this hole at a horizontal and this vertical direction with the help of this multi-transform tool which is given here. We are not going to use the linear pattern tool, we will use the multi-transform tool. So I will select my pocket and go for the multi-transform, and I will switch my part to the isometric. So you can see that pocket 004 has been added here, and here transformation, right click and click on add linear pattern. So here this hole, if you see our UCS in X direction, so I want this pattern at 9 mm horizontal and 16 mm vertical. So horizontal I will say X axis and I will say 9 mm, occurrence is 2. So you can see that hole has been adapted here at the exact 9 mm. Now I wanted to pattern this at a 16. So again I will go and click here and add linear pattern, and this time I will select Y axis and distance is 16, so I will provide here 16. So you can see that this hole is not adapting because our UCS is in Y direction positive we have given, but we want at a Y direction negative. So I will click here and it say reverse directions. Sorry, it is not a 16, it is a 19 here, misreading of dimension because I have considered this edge, but this is 19 here you can see. So I will go and give here 19 mm dimension and I will update it. Okay, so this has been perfectly updated. Now I will okay. Now we will make this hole here, this one. So for this this is on this face, so I will select this face and I will say sketch, and this position center line of this hole is at the center of this width, sorry, this height 6 mm, or we can say thickness also. So I will draw a circle here. We will see its diameter is 5, so I will give it diameter 5. So it is 6, so I will give it a 3 mm. Now I will close it. We will select the sketch and go for the hole, and from here I will select counter bore. So here I will give 3 mm. And now here we will give diameter 5 with depth of 1.5. okay, so this is how to make this counter bore. So first we have selected the smaller one, which is the diameter 3 with depth of 3, and then diameter 5 with 1.5. and you can see that here in a drawing also this hole is opening at the slot here, if you see in the cut. So in our case it is also the same. Here it is opening at the slot, so I will say okay. Now I will switch to the isometric. Now we will add up this radius R1 at all the edges. So I will select all 4 edges, and I will say fillet, and I will provide R1, and I will say okay, and I will switch to the isometric. So this is how we have successfully converted this 2D drawing into the 3D model of gear pump body. I hope you have liked this tutorial, and if you like this tutorial then please like, subscribe and share my channel. And if you want to support my work, then please visit the video description where you will get the Ko-Fi donation page link. I will come with more useful tutorial like this, and I will also provide this 2D drawing and this source file of this tutorial in the video description, so that any beginner user can practice it, and in the case of any difficulty the user can refer my source model. So this is all about this tutorial. If you have any valuable suggestions, then please give your comments in the comment section of this video. Thank you for watching, and thank you for your valuable time.